Yes. Usually when you use Saphira, you're going to see a view like this, which is the certification view, which takes you through every step of the compliance journey, ranging from project setup, document upload, through artifacts like risk assessment and SRS, depending on the type of product you're building. But as you may remember, a common user of the Saphira platform is the safety engineer persona, which is responsible for a number of artifacts like an FMEA and a HARA. So today we're going to go through the state of the art of how Saphira generates and identifies hazards in specific scenarios and artifacts like FMEAs. So the place where a lot of these workflows live is the evidence table. You can see an example of this by clicking on Generate FMEA, even though that's not actually where we're going to start. So on the evidence table, you have a dump of all of the information that lives within Saphira. So historically, this may have been details like product requirements, things that are derived from external requirements management systems or synced to them, but it may also be intermediate artifacts that Saphira creates, like components that are identified within a system. So what we're going to look at today is we're going to consider how we generate a hazard identification for a specific edge case, and then we do the same for a an FMEA. So the starting place is often going to be, again, one of these requirement statements, but we'll actually start from scratch this time instead of uploading something here. So to start from scratch, we're going to add a new item. We're going to name it something new. So we're going to call it just text, and we can give it a general name. We're going to say, for example, this is a block diagram of truck. Actually, a better place to start is going to be something like what we have below, which is actually going to be a task that the vehicle will perform. So we can say autonomous truck drives standard load on empty highway. So a really simple ODD in the daytime. So one of the things that we typically do that we won't show in this particular demo is we'll actually go through and we will identify ODD parameters from a statement like this so that you can ensure that you cover all of the ODD parameters every time you do this. Instead, this time, we've created this item, which is down at the bottom, and we're going to upload a couple images. So to start things off, we're going to upload from right here a block diagram of an autonomous vehicle. And so this is going to be a really simple diagram that you'll see in just a minute, which indicates the inputs that we take to an engine controller and then how that gets output to steering angle and vehicle speed control with braking via the powertrain and automatic transmission. So now what we're going to do is we're going to go through our various generator workflows. So all of this lives, FMEA, HARA, derive items will all take us to the same window, which is right here, which is going to let us select what type of children we want to generate, and then set off the agent to do so given certain guidelines. So let's start off by going through a hazard identification exercise. And instead of using any of the robotics approaches, we're going to actually describe the approach, which we're soon going to log in and make sure appears here for future users of this project. So this might be something like, given the stated or the included block diagram, propose low probability, high severity hazards that are specific to this task in the context of the provided components. Okay, and the key is you can either tell it to go through the whole HARA process in which it rates all of this, or we can do that later. And you can specify a maximum number of hazards to propose. So we're actually not going to give it a max, and we're instead going to tell it, okay, go off on your own and keep on trying to load this until you think you've reached a satisfying point. And what it'll start sending us back in just a minute is a current state of what it has put together, which we can then stop. So the idea is that this allows us to set an agent off, coming up with as many hazards as we need until we are good to go. So a minute later, we come back with everything down here, potential software-based failure in engine control.